Dear students, today I would like to discuss about the topic Bernoulli Trails. Any experiment which involves only two possible outcomes of an trail is nothing but Bernoulli Trails. Any experiment which consists of only two possible outcomes on any trail, which is known as Bernoulli Trail. Example, tossing a coin, passing or failing an exam, receiving bit 0 or bit 1 in a computer bit stream, winning or losing a game, hitting or missing the target, etc. For such type of experiment, let A be the elementary event having one of the two possible outcomes as its elements. A bar is the only other possible elementary event. We shall repeat the basic experiment n times and determine the probability that A is observed exactly k times out of n trials. Such repeated experiments are called Bernoulli trials. Assume that elementary events are statistically independent for every trial. So let P of A be T and probability of A bar be 1 minus T. After n trials of the basic experiment, one of the particular sequence of an outcome has A occurring k times, followed by A bar occurring n minus k times. Because of assumed statistical independent of trials, the P of A, the probability of this sequence is given by P of A into P of A into P of A and so on to k times. P of A bar into P of A bar and so on to P of A bar n minus k times. So if you multiply all these things, you will be getting it as P of k into 1 minus P whole power n minus k. Now there are clearly other particular sequences that will yield k events A, n minus k events A bar. The probability of each of these sequences is given by equation 1. This is equation 1. Since sum of all such probabilities will be desired probability of A occurring exactly k times in n trials, we need to find the number of such sequences. This is the number of ways of taking k objects at a time of such sequences. This is the number of ways of taking k objects at a time from n objects. Then the number is known to be nck. N factorial divided by k factorial, n minus k factorial. Let us take it as equation 2. Now, from the product of equation 1 and 2, the probability of A exactly occurs k times is given by LCK e power k 1 minus p whole power n minus k. Suppose certain machine gun fires around for 3 seconds at a rate of 2400 per minute, and the probability of any bullet hitting a large target is 0.4, and find the probability that exactly 50 of the bullets hits the target. To solve this problem, n equal to 3 into 2400 by 60 equal to 120, k equal to 50, p equal to 0.4, n equal to 120 into 0.4, that equal to 48, and n into n minus p equal to 120 into 0.6 equal to 72. Thus, n comma k and n minus k equal to 70. All are large values. So, probability of exactly 50 bullets hits the target is LCK p power k 1 minus p whole power n minus k. If you simplify that, you will be getting it as this answer. With this, your first unit has been completed. Some of the assignment problems are there here. I'll be sending these assignment problems through mail. Please try to complete it. If you have any doubt, please can come up so that we'll be solving on the board. First part of the first unit has been completed. The next topic is random variable. The random variable.